Good evening to all. Chapter is alcohol, phenols and ethers. So first we will discuss about of alcohols. So if we say this alcohols, we write it ROH, where secondary suffix HOL. So how we do that? If we say that alkene, and if I remove H and if I add OH, then from alkene what I get, going to get alcohols. So if we write the classifications, of alcohols, what I said, if one OH group is present, then that is called monohydric alcohols. Alright, direct first class is monohydric alcohol, means one OH group is present. OH group present. So if I write, so let me okay, so let's write CH3 CH2 OH. So one OH group is present, so this is it, 1 degree alcohols. And similarly if I write CH3C CH3 CH CH3 OH. So here that is 2 degree alcohols. So we can write this as methane, ethane, propane. So propane 2 and if it is 3 degree, then this is 3 degree alcohols, but everywhere one OH group is present. So one OH group and one OH group. So this is, we can message 2-methyl propane 2-ol. Yes. So for if one OH group is present, then that is called monohydric alcohols. It may be 1 degree, it may be 2 degrees, it may be 3 degree alcohols. And if more than one OH group is present, if that is polyhydric alcohols, we say, means more than one OH group is present. Let's say more than one OH group is present. Let's say CH2 OH OH. So here, what is this is ethane 1,2 diol, means 2 OH group is present. Like say if 3 OH is present, like H, that is what? Propane 1, 2, 3. Methane, ethane, propane. So propane 1, 2, 3 triol. So like that. So this actually common names is ethylene glycerol, and this is glycol. So these are the common names. So this way you can classify that alcohols. If one OH group is present, this one OH group is attached to the groups, then that is called monohydric alcohols. If two OH groups is attached, then that is called polyhydric alcohols. So another way the classifications we can do. This is alcohols. So one is allylic alcohol. What do you mean by allylic alcohol? Means here OH group is attached to carbon which is adjacent, which is OH group is attached to carbon which is adjacent to the carbon of double bond. What do you mean by, let's say CH. So our OH group is attached to carbon which is adjacent to double bond, Hence here carbon is there. Okay, so the allylic group means that OH is attached to the carbon, yes, this carbon, which is adjacent to the double bond. So this is adjacent to this double bond group. So if this is there, that is allylic alcohols. Next, vinylic alcohol. Here that OH group is attached to carbon which is in double bond. I mean that is CH2 CH and OH is attached to carbon which is in double bond. So our OH group is attached to the carbon which is in double bond. But this state is not stable. So what will go? It will be converted into ketoforms. So what happened? That 1, 3 hydrogen shift occur. So let's say if you take the OH group 1, then this is 2, this 3. So this hydrogen will shift from 1 to 3, and this double bond will shift here. So this will become what? CH3C. So this will shift it to here. So OH, or I can write this is shifted to here O, and this H is shifted to here, that is CH3. So here remain CH3. So you can write it as CH3. This is ketoform. Okay. So we will discuss this more in further classes. Now another types is benzylic alcohols. benzylic alcohol. But here that OH group is attached to carbon which is adjacent to benzene ring. So what it means, suppose this is the benzene. Yes, so here CH2, so OH is attached to the group which is adjacent to benzene ring. So this OH is attached, this is adjacent to this benzene ring. So this whole is termed as benzene ring. So that OH is attached to the carbon which is adjacent to the benzene ring. So if this positions OH is group present, then that is called benzylic alcohols. So and if OH group is present to the carbons which are direct with double bonds, then that is called vinylic alcohols. And allylic alcohols, if OH is present to the carbon which is adjacent to double bond, then that is called allylic alcohols. Okay. So next we will discuss the preparations of allyl alcohols. Next, that is preparations of alcohols. Okay. So first is from alkyl halide. So it says that any RX alkyl halide is present, and if we keep that aqueous KOH or aqueous NaOH or aqueous AgOH, then we can prepare that alcohol ROH. So this is the first way of preparations of alcohols, that is from alkyl halides. Okay, so let's say the example. This is CH3 CH2OH is there, and if you give aqueous KOH, then what will going to give CH2X, then it will going to give CH3 CH2OH. But demerit of the limitations of these reactions, limitations is that whenever you are doing the aqueous KOH, so this is the happening the substitution reactions. So this is substitution reactions, means in the place of X, OH we are coming. But at the same time, so what happens, the elimination reactions also possible. When you give aqueous KOH, elimination reactions also possible. That is, this will be removed and this positive form is there. Then what happened, that this will going to become CH2 double bond CH2. So elimination reactions also possible in step by step. So our expected product is this, but side by side elimination reactions also occur. So our product, good amount of product may not be pop. So this is the limitations of all these reactions. So this reactions is not so much favor for the synthesis of alcohols, but in the exams whenever they write the preparations of alcohols, then we can write this one. Okay. For industrial process, this is eliminations occur, so this procedures is not always favorable, but for exam cases we can write this preparations of alcohols from alkyl halides. Then the second is from alkene. Alkene how? Like if we have CH3 CH2 double bond CH2, and if you give water and in the reagents, because water is not so reactive, so we have to give some reagents. Then what happens is 3CH, let's say this OH, H, H, H. So OH will come if we give water with some reagent. So with this, that 3OH we can synthesis alcohols from alkenes, but is acid catalyzed of water additions of water. And third is hydroborations, oxidations. And another way is oxymercurations and demercurations. So these are the three processes we can synthesize the alcohols from alkenes. So first we will study by acid catalysis of additions of water, and then we will discuss hydroboration, oxidation, then oxymeration, demercurations. So if I say that acid catalyzed of additions of water, what happened in these reactions? Let's say this is our alkenes, and what is that? If I add water, and with that one acid I have to add, H plus comes from any acids like dilute H2SO4. So this H plus comes from dilute H2SO4. Then what happened that due to this H plus, this double bond, so this double bond is electron rich and H plus means electron deficit. So whenever this H plus come contact to this double bond, then this gets polarized. So it will becomes CH3C2. So two ways this double bond can break. Either this bond means is equal to plus and minus. So plus and minus is equal to this bond. So what I did, when this H plus comes near to this double bond, this is break. So plus and minus. Yes. Now what happened? That here we have to look that which is stable. So carbocation, generally this carbocation is forming. So here the carbocation is 2 degree, here carbocation is 1 degree. So we know that carbocations 3 degree is more stable than 2 degree, then 1 degree. So here 2 degree formation is occur and 1 degree formation is not occur. So because 1 degree carbocation is less stable than 2 degree carbocation. So this will not form and this will form. After that, we know we have the water. So here lone pair is there. So here positive charge, this is electron rich lone pair. So this will attract here. So CH3C, here O. Lone pair of water is attached to this positive charge. So this get positive charge. Yes. And then what happened? This since oxygen is electronegativity atoms, and if positive charge is coming to the oxygen, then this is highly unstable. So this will attract these electrons from this oxygen hydrogen bonds towards itself. Then this H plus will, this is minus is there, and this H plus is there. Then this negative charge is attached to this. So what happened is CH3 CH OH CH3. Okay, so this is the final product. So what happened in this mechanism? This is the mechanism. What happened in this mechanism? That carbocation is forming. So here intermediate is carbocation, and if carbocation is forming, then rearrangement is possible. Rearrangement is possible. So if 3 degree to 1 degree is given, then that will, if there is any chance to form 2 degree, then that will convert to 2 degree, and if chances to form 3 degree, then that will form to 3 degrees. So rearrangement is possible. Okay. Let's solve some one examples. If I write the find the major product, so if example is find the major product on hydration of the following alcohols. So if given is CH3 CH double bond CH2 B CH3 CH2 CH double bond CH2 C CH3 CH3 H CH double bond CH2. So what is the major product and hydration? So if we give that hydration, then what is the major product? So if we see here, then case of A, so if it will be H plus will comes, then what happens? The carbocations will form. So carbocations can form here and here. So here that CH3 CH 2 plus minus, or CH3 minus. So because this is 2 degree, this is 1 degree, so this is major product. So what happened, that OH will come here, so this is the major product for this case of A. And for the case of B, then what happened, that whenever do the hydrations, then what happened, that here this can form CH3 CH2 CH. So just break this double bond, either plus here minus, or CH3 CH2 CH CH2 plus. So this is how much? This is 2 degree and this is 1 degree. But so this will not form because this is 1 degree, this is 2 degree, because 2 degrees prefer than 1 degree, so this will not form, so just erase it. So now that OH will, H2 will attack, so it will form CH3 CH2 CH2 OH CH3. Okay. And for the last case here, so you will just break these double bonds. So CH3 C CH3 H. So if I break it, then CH CH2, suppose I put plus here, minus. Another way, that is just break these bonds. So CH3 CH3 H CH CH9 I am putting plus here, I am putting minus here. So here this is 2 degree, here this is 1 degree. So this is not for, this is for, okay. So now, since this is 2 degree, again another arrangement is possible. Okay. So half 4, you have to remember, half 4, that is first hydrogen shift is occur, then phenyl, then any methyl groups. So here hydrogen is there and methyl group is there. So first half H is prepared. So since 2 degrees, so if hydrogen is shifted here, then this is come to 3 degree, and both CH3 and H, anyone can shift, but the order is half 4. First is hydrogen, then pH, then methyl. So H will shift. So this will going to give CH3 plus CH2 CH3. Now OH will attach here. CH3 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 CH2 CH3 OH, and this is 3 degree. So 3 degree is most stable. So arrangement, if carbon formation is happening, then arrangement is possible. So today after this, tomorrow we will discuss oxymeration and demacerations and hydroboration and oxidations. Thank you.